Time, if you guys remember how we talked about if a series has a bunch of plus, minus, or pluses for a while, then minuses for a while, that action of pluses and minuses significantly aids in convergence. It helps. And so one of the things we will discuss, and it's going to kind of lead us into our final test, but we only have one more convergence test to discuss. It's coming up next, later on next week, or tomorrow. I guess it's tomorrow. Anyways, and that is the question of, all right, if we took away all your pluses and minuses, would you still converge? Or do you have to have the pluses and minuses? Because they help. So if I take away your help, do you still converge, or do you have to have them? So if you take them away and you still get convergence, that means that that series is absolutely convergent. But if it needs the pluses and minuses, it's called conditionally convergent. Because that series only converges on the condition of it gets to keep its pluses and minuses. Does that make sense? So how do you take away pluses and minuses? Well, yeah, you do absolute value, right? You do absolute value of whatever that is, and that absolute value will take anything that was a minus and make it a plus. Anything that was plus will just remain a plus. So, I'm wondering if you guys could take a look at number 2 and answer the question of, is this series convergent or not? And furthermore, is it absolutely convergent or conditionally convergent? And arrive at a good place with that. So please look at number 2. That'd be a first. I'm sorry, Anderson. I was hungry. You just want to check convergence first, and then do the absolute conditional.
70-30, that's how we split it. 73 table cover, there it is. 60-30, yeah.
Just let me know.
Yeah, just for my day, because I would consider it. I'm kidding. 80,000. After taxes.
See what shows up?
You're like, we're not going to pay you someone to say
That's why they're thinking about you.
At what point do they like
Have you guys figured out that this series as it stands converges? So that's right. So once you've decided that, you want to take that one step further and say, okay, well, is it absolutely convergent? Or is it just conditionally convergent, right? So it does converge. Let's decide whether it's an absolute or conditional convergence.
How about some other story?
What station you got? It used to be cozy. That's how it used to be. Nobody knows. I feel like it just appears on the floor.
It's like one of
Taylor Swift's concert?
yeah.
Oh, Catholic radio. Oh, yeah.
Yes.
Hey, Jacob. You know that Juju song they all
Well, I love that.
You're a Catholic song?
Oh, the 5 notes.
Okay, oops. Based on all the work we've been doing, I'm hoping that the first thing you did was recognize that it's an alternating series. So hopefully you wrote, is an alternating series. And then you proceeded to consider the conditions for that, right? So maybe you did limit as n goes towards infinity of 1 over n. Well, that's 0. And if a sub n equals 1 over n, then a sub n plus 1 would be less than a sub n for the interval 1 to infinity. So in other words, we're going to see a steady, consistent decrease towards 0 on the nth term. And the fact that it's an alternating series combined with those two conditions lets you arrive at a converging series, right? So you could say, therefore, that series converges. So then, as I said, the extension to this is, all right, well then, does this series converge absolutely or conditionally? And so what we do here, of course, is we take away the alternating element. So we'd say, does this series converge from n equals 1 to infinity? If you do the absolute value, it's just 1 over n, right? We've taken away that alternating element. So does that series converge? What do you say? No? Why not? It's harmonic. Or you could do a p-test, or you could do an integral test. Options are open, right? So I would go with the harmonic thing just because I think it's a little bit easier. So we could say, is a harmonic series, therefore it diverges. So then our final conclusion would be to say, therefore the original series, with its alternating element and everything in there, is what kind of convergent? Conditionally, yes, because the minute we took away its help, it diverged. So it's conditionally convergent. Conditionally based on it needs its alternating element, right? Take it away, it doesn't converge. Dylan, question?
Yeah. So for this series by itself, can you say it's an alternating harmonic series? And then is that all the proof that you need, or do you have to actually do the AST?
No, you could say an alternating harmonic series. They always converge. Yeah, we could have shortened that up a little bit.
Okay.
Yep, I like it. Alternating harmonics do converge, always, yeah. Good question. Any other questions on number 2? Alrighty. Take a look at number 3. If you haven't already. Mm-hmm.
With ones like these, like if it's just out of context and it's not like we're always doing conditional consistency, do we have to, like if it's convergent, always do the conditional, we always go the extra step and specify what it is?
No, if it just says, hey, does this series converge or diverge, you just take it as is. You don't have to extend it into the conditional or absolute consideration. Yeah, if it does say, hey, conditional or absolute, then you can go to what we just did. Otherwise, yeah, just take it on face value.
No, Brandon, I tried to prove the alternating series.
What is it, Josh? Josh, I thought you were good at math.
So did I.
That's the last thing you get is a social security number asking for a ride.
Actually, Josh, oh yeah, what's the last one? That's nice, Josh.
What are you talking about? I know my social security. I told you that it wouldn't be a surprise. No, that's literally what you said. You said it's an SSSN. Wait, no, it's an SSSN.
I said SSSN number. It's a surprise
It's a noodle
social security
number.
number.
There you go.
So I'm hoping number 3 you might have already reached a conclusion. So maybe you did this. Maybe you looked at this and I think this makes a lot of sense. Did you notice like immediately it's an alternating series? So you say, okay, it's an alternating series. And then as you start to explore the conditions for convergence with this alternating series, the first one is this. The limit as n heads towards infinity of the nth term, and we don't worry about the alternating part. And when you calculate this limit, what do you get? Not zero. Yeah, you actually would get infinity here because that n factorial would eventually grow infinitely faster than the 2 to the n exponential down there on the bottom, which of course most importantly is not what? 0. So we stop right there and say, therefore, that series diverges. And there's nothing more to be said about that. So in other words, as you guys remember, the alternating series is kind of the soccer mom of series tests. This series was so bad, didn't even get a juice box after the game. They just said, go home, you diverge. Sorry, if any of you just cried, I'm sorry. Okay, please move on to number 4. Ready, go. Sir. Please move on to number 4, go.
Are you holding us all just like that?
No. You have to like jump and get the ball. No, she was trying to kick the ball, but she wasn't. She was trying to kick the ball. She just did. Oh wait,
Maybe she's actually loud.
Next Friday we commanded. Saturday we.
Without that,
I give nobody the benefit of the doubt. Nor self. Josh 3, 2, 1, I'm out of here.
Actually, like,
Put that number or that.
90, 10, 0.
You're out of the country.
Yeah, I started a new company.
Whether, you know, whether they counted or not, that's the problem.
I don't have to tell you.
I don't know that this will show up on a free response twice. Buy out your basic test.
Really cute.
Equally.
We didn't go in the app like,
Number 4, it was pretty scary.
yeah.
act like you want to.
Jack, are you gonna go to some sort of site?
This is all.
I don't know what that's supposed to be.
Wait, you can see the AST, John.
Alternating. What are you talking about?
Don't talk to me.
I think so, 1 over 3 to the n, you get 0. Oh, but that's what it tells me. Oh, but that's a, that is
Sort of last dish. It's definitely not.
let's look. That would be a P test. I'm not gonna be alone all the time. Turn 3. That's what
Make sure you test out the barbecue too. Yeah.
Oh, geometric, 1/3. Oh, wait.
Sorry, Alabama, Texas Tech.
Well, one True. I'm so smart, I never saw it that way, I just did it because we do it that way. So that goes to, and R is in between it, so it converges to A over 1. Sorry. Do we need to find what it converges to? Yeah, it converges.
Or you could just judge the value of R. Judge the value of R has to be less than.
Space out about the
Which is the
rest.
same thing.
Look at it.
You either have to designate, you can't just say R is less than.
It doesn't.
I know what you're supposed to do,
It
Josh.
doesn't.
If R is less than 1, R would be like negative 17.
C squared, not C squared equals B squared. I got more.
Things are-
I'm looking for y-axis distinction.
Like, what is the?
Hey, I didn't make a difference.
That's freaking spicy.
I'm gonna need you to watch your language, okay?
Ooh, that wasn't directed for you.
Yeah, but I'm in the vicinity. Wait, so.
Yeah, but she's in the vicinity.
I'm in the vicinity too.
I bet you are. I bet you are.
Kidding me? You're out of the company.
Good. I'll take
As
that.
a primary shareholder, you're out of the company.
I trademarked that.
She's on her own company. We're so cat.
No, he's out of the company. I just kicked him out.
I don't care, out of my.
Yeah, as a shareholder, that's my right.
Tim Cook, you're out of that one.
Yeah, a little more writing, a little less than just computational.
You know what, Jeff Bezos? You got it, Trump. Elon Musk, nice try.
Sounds like a fictitious name. Names their kid Elon.
Clearly a cover.
Undercover
You could always
cop,
just
you're
write-
out of the company.
You could always shorten it up, but you could always. Gosh, you know what you could do to help yourself a little bit, it's like at the very start, you say a sub n equals 1 over 3
Don't.
or sigma of a.
I'm sorry, Lynn, but I'm trying to.
There, enjoy the journey.
The life's not. Yeah, I got a journey. So, I'm sorry, it's a
Freeway.
freeway.
I don't know about that one.
Do that to the rest of the
How does that song start? Except for 2 words for the verse.
Just to say that.
It's possible, honestly. Except for the chorus.
So as far as that, it's
What did they change?
like that. So you could, okay.
My original
Okay, so, okay, let's see.
7% of rascal lines. I am
Okay, so if,
I am big
that would be your text.
I am a big
Makes sense. So, either way, like, this is multiplying geometry. So it and that's why, like, you're
quadrometer.
So, to just say, hey, my R is less than 1 is not sufficient, because somebody could say, what if R is negative 9?
What is out?
Still. Right? Does that make sense? Yeah. All right, let's finish this one off. This will be our last one for the day. We'll save number 5 as a warm-up for next time. So guys, here we go. Was anybody like mildly intimidated by the numerator? Hey, look at that. There is a lot of stuff going on. Can anybody define what the numerator is?
The alternating.
Yeah, the alternating pattern is like sort of complicated looking, but that's all that is. That's just the alternating element. That's it. So when I look at this, all I really need to say is that this is an alternating series, and then we go through our other conditions and say the limit as n heads towards infinity of 1 over 3 to the n equals 0, and if a sub n is that nth term there, then we can say that the terms steadily decrease towards that 0, right? For every next term, it's a little bit smaller than the previous term. So we can say, therefore that series, I'm not going to have nearly enough room. I'll come down here. Therefore, this series converges because of the alternating series test. So, and of course, Brandon asked a good question that I think is worthy of everyone hearing. He said, hey, if you recognize that an alternating series really does converge, are we like just expected to automatically consider conditional or absolute convergence? Does that make sense? And the answer is no. Like if it just said, hey, does this series converge or diverge, and you answer that, you're done. But if it does say consider absolute and conditional like the instructions on this did, that's when you got to take it this one extra step further. So what I'm going to say now is, does this converge? 1 over 3 to the n. So did you guys recognize what kind of series this is?
Geometry.
Yay, it's a geometric. Yes. And so we can say is geometric. And what is the r value? Yep, so I'm going to say and r equals 1/3. So what's so important about the r equals 1/3? How is that going to help us? Between 0 and 1, right? So there's a couple ways you could write this. So we could say this. We could say, therefore, this is true. Or you could say this is true. Or, to be honest, you could say this is true. All three of those things would be sufficient proof that that series does what? Converges. We can say, therefore, this series converges. And that's GST. So what can we say about the original series? That it converges conditionally or absolutely?
Absolutely.
Absolutely, that is true. Because if you take away the plus minus, it's still converged. Josiah, while I'm finishing this off, you had a question.
I was just going to ask you about the absolute value.
Yep. Did I answer it for you? Okay. Absolutely converges. Okay. Question?
Do you not have to show the absolute values of the
Say again?
Do you not have to show the absolute values of the
Not really, because I've kind of done that here. I've taken away the alternating element, so like that would be the result. No. Nothing wrong with that. I mean, if you had a previous step like right here that said, hey, the sigma of absolute values of that original, and then proceeded from there, obviously that's really good communication. I've just written the result of that. I think we're good either way. Okay, other questions? Yeah.
So for like any alternating series, should we test to see if it's absolutely convergent?
If you're directed to do so, yes. If not, nope.
Okay.
Yeah, because otherwise they're just asking, hey, does this series just converge or not?
So if we just saw this without any context.
Yeah, just consider the alternating series and don't consider absolute or conditional. But yeah, since this one had those directions, we got to consider. Anyone else? Question? Concern? All right, so then what that means is tomorrow we'll leave number 5 as a warm-up, just to see how you're remembering this, and then we'll move on with the ratio test then. But for now, I want to hand back your quizzes from before.